Hello, Math 120, and this is Professor Gonzalez, and I would like to do some problems in homework section 7.3. 7.3 is all about taking a look at equations that are quadratic in form. So they're not exactly quadratic equations, but they're quadratic in form. And let's see, there's the language right there. Write the equation, it's in the form of a quadratic. So really what we're looking at is we're trying to write the equation as the variable raised to the second power plus or minus that same variable raised to the first power, and then you have a constant and it's equal to 0. So that's the idea, that's what we're looking for. And you can see in this particular problem we have p to the fourth power. And let me just tell you, one of the keys to doing these problems, it works on every single one of these really, is, in my opinion, is to take a look at this second term right here. And that usually, well, in every case in this class, every case, that is going to be, in fact, what your u sub is going to be. But let's continue to talk about this for a second here. Basically, what we're doing is we're trying to see, can we get this equation to look like this form? And that would be, you know, our quadratic has, basically, here it is, something to the second power, and then we have that same something raised to the first power. Okay, well, if I rewrite p to the fourth as p to the second raised to the second, right? This thing right here is the same as p to the fourth. And if I write this as p to the first raised to the first, p to the second raised to the first, that's still p to the second right here. So essentially what I just did was I did a u sub. I'm going to replace this, let's see, because of color, I'm going to replace p squared with u. So p squared gets replaced with u. And now we have, you can see, you have u to the second minus 13u equals 48. You got a quadratic. Now let's put it in quadratic form, in standard form. So all we have to do is subtract 48 off both sides, right? And we get u squared minus 13u minus 48 equals 0. So now we actually have a quadratic. We're going to solve this quadratic. After we solve this quadratic, we're going to sub back in what it's supposed to be, right? You replace u's with p squares, and now we're back to the original problem. But by doing this, by turning it into a quadratic temporarily, it allows us to use all the work and all the methods that we have of solving quadratics. Like what? Number one, set it equal to 0 and factor. Use the zero factor property and go for it, right? So set it equal to 0 and factor. Another technique is complete the square, right? Another technique is the quadratic formula. So as long as we can write this as a quadratic temporarily, we can use all these techniques to help us out. That's the strategy in 7 point whatever we're in, 7.3. So we have this written as a quadratic. So now we want to factor it. So essentially what we're looking for is what two numbers multiply to negative 48 and we'll add to negative 13. And what's that going to be? A negative 16 times 3. Multiplies to negative 48 and adds to negative 13. So this just factors down to u minus 16 times the quantity u plus 3. Okay, now we use a zero product property. We set each factor equal to 0. So set that factor equal to 0 right here. And add 16 on both sides, and we get u equals 16. Set the second factor equal to 0 right here. Subtract 3, and we get u equals negative 3. Now remember, we didn't want to know what u is. We were looking to solve for p up here back at the beginning, right? Solve for p. But we did a u sub to temporarily make this a quadratic. Now, substitute back in. I'm going to put a little let statement, because usually with these things we have let u equal p squared, right? So at the very beginning we replaced p squared with u. And now what we want to do is we want to replace u with p squared, sub it back, right? There's u equals negative 3, sub it back, p squared equals negative 3. Now you in fact just solve for p squared. Well, how do we undo a square? We square root. And we never forget when we square root both sides to say plus or minus. So we're going to get p equals plus or minus the square root of 16, so plus or minus 4. And over here, we're going to square root both sides, never forgetting the plus or minus. P equals plus or minus the square root of negative 3, so it's going to be the square root of 3i, because of the negative under the radical. And there we have 4 solutions. Okay, now they want us to verify the solutions, and we can do that. We can do that easily by just substituting my answer of 4 into the original equation. And you can see they're going to raise it to the 4th power, which gives you 256. And then they're going to multiply, let's see, this is 4 squared, which is 16. Anyways, do the math, and the left equals right. 48 equals 48, so that's true. Then we're going to try it with a negative 4. And negative 4, because it's going to be raised to an even power, and negative 4 is going to be raised to an even power, you're going to get the same exact thing as last problem, so that's 48 equals 48. And now we want to try my answers over here, right? This positive root 3i, positive root 3i, so positive root 3i. They put the I first, which is not exactly the proper form. I understand why they do that, because they want to make sure you don't put the I under the radical. So I get that strategy. Anyhow, I like to stick with the form by putting the I to the right. But we want to try the square root of I. And you do the math there, right? And you get the square root of 3 to the 4th power, which is square root of 81. Well, that's just 9. And then how does this I simplify out? Well, we have I to the 4th right there. And I to the 4th is I squared squared. So I squared is negative 1. Negative 1 times negative 1 is positive 1, so that's good. Anyhow, it simplifies out, and the left still equals the right, so that's true. And when we use the last one, it's just the negative square root of 3i, negative square root of 3i. The only difference is the negative, and we're raising it to an even power, so you're going to get the same exact result on the last problem. Okay, and so there it is. We checked everything, and it all works just nice and perfect. Let's take a look at what we just learned. It says, or actually the language of it, it says that it says if a substitution u transforms an equation into the form au squared plus bu plus c equals 0, then the original equation is called an equation that is quadratic in form. It's not exactly a quadratic equation, but once again we put it in the form of the variable squared plus that variable to the 1st power plus some constant value equals 0. Of course, if we put in our general form, that's a there and a b there. Okay, let's take a look at number 3. Solve the equation. Well, in number 3, this is definitely not a quadratic, but the big question is, can we actually put it in quadratic form? What is quadratic form? Well, it's when you have something squared plus 34 times that something variable to the 1st plus 225 equals 0. Can we do that? And I'm going to tell you, just like I did at the very beginning, that really the key here is that linear term, this guy right here, and the original problem, that variable, it always tells you what you want your u sub to be. So I'm going to let u equal that highlighted q to the 2nd. Now you might not see what that's doing yet, but check it out. When you put q to the 2nd here, I think it'll become clearer. Wait a minute, okay. This new equation that I just wrote right here is equal to the original equation. And it is, because q to the 2nd raised to the 2nd is q to the 4th. Right? And q to the 2nd raised to the 1st is just q to the 2nd, and everything else is the same. So what we did was we just sort of massaged it into this quadratic. You can really see the form, right? Here's our second, you can see our 2nd power, and then our 1st power, and then our constant, and that's a quadratic. So now to really make it a quadratic, we have to do our u sub. We replace q squared with u. So this gets replaced with u, and now we definitely have a quadratic. U squared plus 34u plus 225 equals 0. Okay, so now we have to do, well, the work that we normally do. What multiplies to 225 and adds to 34? And you can search, search, search. How about a 9 times 25 is 225. I'm going to add that up, I get 34. Now the fact is this does have a leading coefficient of 1, which is beautiful, because all I have to do is just factor it down without having to group it or anything special. U plus 9 times a quantity of U plus 25 equals 0. And you could double check that by multiplying that out. You'll find out that that is true. And therefore, we are using the zero factor property, so that each factor equal to 0. So U equals negative 9. Set this factor equal to 0, so U equals negative 25. And now remember, the original problem is we want to solve for Q, not U. So do your substitution. Wherever you see a U, replace it with a Q squared, just like our let statement. This is like our key at the beginning, right? Wherever you see a U, replace it with a Q squared. And now solve for Q squared. And so you can see that solving for Q now is much easier because we did all that work as a quadratic. How do you undo a Q squared? Well, you could undo a Q squared by square rooting it. So if I square root the left and square root the right, we never forget our plus or minus. And this is going to result in Q equals plus or minus. So the square root of 9 is 3, but because of the negative, it's going to be plus or minus 3i. Okay, and there's our answer. Okay, and let's do it again right here. We can undo the squaring by square rooting. We square root both sides, never forgetting our plus or minus. And we get Q equals plus or minus the square root of 25, right? It's just 5. And the negative on the radical is an imaginary number, 5i. So for number 3, we get 4 answers. And it is Q. It's Q equals plus or minus 3i, or Q equals plus or minus 5i. By the way you answer this, the easiest way to answer it, I think, in MyLab, they have you put it in braces, and there is a symbol. Once you highlight or once you click on the cursor into the answer field, or whatever you'd call that, you'll have some buttons that'll pop up, and one of them is a plus or minus. Click on the plus or minus and then write or type in 3i, comma, click on plus or minus and type in 5i. And that's probably the easiest way to put it in the computer. Okay, next problem. Same problem here in the way that this is not a quadratic, but it will be quadratic in form if I could write this as 9 something to the second power minus 85 something to the first power plus 36 equals 0. And like I said, every single time this actually does work. If you take a look at that term right there, the term that is supposed to be, right here to the first power, if you take that, that will be your let statement. Let's let U equal a squared. And this might not be obvious at first, but if you look closer, you'll realize if I put in an a squared, let me zoom in a little bit here. If I put in an a squared here, and an a, wow, it's hard to see. And I put in an a squared here, you will see that a squared raised to the second power is just a to the fourth. So that matches, and a to the second raised to the first is just a to the second. So that matches. So those two equations are identical, and that helps you to see that I'm going to do my u sub. I'm going to replace this a squared with u. Replace this a squared with u. And so then I've got 9 u squared minus 85u plus 36 equals 0. And now I definitely have a quadratic. So how do we solve this quadratic? Well, this gets a little bit tougher in the way that, we've got a leading coefficient of 9. So I like to think of this 9 times 36, kind of a big number. So I actually kind of do it this way. I just say 9 times 36. That's what that is, because I'm going to factor 9 times 36. 3 times 3, 6 times 6, 2 times 3, 2 times 3, 3, and then there's another 3. So I prime factored it. You don't have to prime factor it. If you can find what multiplies to 9 times 36 and adds to negative 85 without factoring it, that's fine. But sometimes I find when this number gets kind of large, just factoring it down for me makes it easier to see combinations, because when I multiply all of these prime factors together, I am insured to get this. So now, in order to get a negative, add up to a negative number and multiply to a positive number, both these numbers are negative. So they're basically going to have two numbers that add together. Okay, and so I sort of messed around with a couple numbers, and eventually I saw this combination right here. I saw a 3 times 3 times 3 times 3, and when I did that, that gave me 81. And then I saw 2 times 2, and that gave me a 4. And now I'm insured that that'll multiply to 9 times 36. In fact, if you multiply that out, 9 times 36 is what? 324. But making that a big old number of 3, making that 324, I don't see how that's helpful. It's just a big number, right? So anyways, I can now see that if I add 81 plus 4, I get 85. So I can now see it's 81. Negative 81 times negative 4 gives me that big number of 324, or 9 times 36. Also adds to negative 85. Okay, so yeah, this one's tougher one because it's a tougher problem. Now, a tougher problem in terms of that factoring piece to it. You can factor this in many different ways. I'll just go ahead and do the way that we've done in the past by grouping. So that's just going to be 9u squared. Replace the 85u with our two pieces, our target numbers, if you will, negative 81, negative 84. So negative 81u minus 4u is exactly what 85u is, negative 85u. And then I copy down plus 36, and you know this, right? You just look at the grouping here. What can you factor out? And that would be a 9u. And what's left after you factor out that 9u? Well, u minus 9. So I'm going to need to match u minus 9 here if this grouping technique is going to work. And what can I factor out of the next binomial next to? I can factor out a negative 4. Let's see if that worked. Negative 4 times u is negative 4u, and negative 4 times negative 9 is positive 36. So that worked beautifully, and we factored it down to u minus 9 times the quantity 9u minus 4. And like I said, you could have gotten there in multiple ways of factoring. By the way, is factoring the only way we have? No. You could do this problem by factoring. You could also say, I don't even want to factor that big problem. I'm going to use the what? You can complete the square. That would also work. Although most people I don't think would do that. What's a possibility? Complete the square. Another possibility is use the quadratic formula. Just as long as you memorize the formula. So you could have done this problem by completing the square or quadratic formula. You could also do it by factoring because it was factorable. Okay, so anyhow, we have solved for u. Use the zero factor property. Set the first factor equal to 0, and u equals 9. Set the second factor equal to 0, and we've got 9u equals 4 divided by 9 on both sides, and we get u equals 4/9. Okay. So here are my two answers for u, but I want to solve for, what was the original problem? I want to solve for a. So I go back to this original piece, and wherever I see a u, I replace that u with a squared. So wherever I see a u, I replace with a squared. And so you can see the problem is a much easier problem now. How do you solve or simplify a perfect square? Well, you square root both sides, never forgetting your plus or minus. And when you do that, you get a equals plus or minus 3. and you square root both sides, never forgetting your plus or minus, and you get a equals, let's see, a equals plus or minus, the square root of 4 is 2, the square root of 9 is 3. So you get those 4 answers. Plus or minus 3, plus or minus 2/3. And let's move on. Number 5, solve the equation. And their example was that I think they did a sub first, but I wouldn't do that. I just set it equal to 0. So that's what I do first. Let's put this in standard form. This is p to the 4th. I'm going to subtract this 18p squared on both sides, right? So I got minus 18p squared plus 77 equals 0. Okay, got it in standard form, but it's not a quadratic. But is it in fact quadratic form? Can I write this as a square and then to the first power, constant 77 equals 0? And the answer is yes. What's my recommendation? Don't panic. Just look at that what's supposed to be the linear term right here, right? Because you know this is to the first power. So that every single time will tell us, let u equal p squared. So if I go ahead and put p squared in here and have a little bit of faith, let's see. P squared is p to the 4th. That worked. And p squared to the 1st is just p squared, and everything else is the same. So those two equations are equal. So far we have equality. Now we're going to use our u sub, and we're going to replace p squared with u. Now we definitely have our quadratic. Okay, now we're looking for two numbers that will in fact multiply to 77 and add to negative 18. So you search, look. And what do we get? Well, how about 11 times 7? Now it's going to be a negative 11 times negative 7 is positive 77, and negative 11 plus negative 7 is negative 18. The fact that there's a 1 here, we don't have to do any special grouping or anything. It's just u minus 11 times the quantity u minus 7 equals 0. Now let's set each factor equal to 0. So therefore u equals 11. Set the second factor equals 0, u equals 7. I didn't want to solve for u, I wanted to solve for p, so I need to make sure that I replace my u's now with p squared. I substitute it back. Now that I've got the problem under control, I replace u with p squared, replace u with p squared. So now I've got p squared equals 11 and p squared equals 7. How do I solve that? Well, I square root both sides, never forgetting plus or minus. And now I got p equals plus or minus the square root of 11. And I've got, once again, square root both sides, never forgetting plus or minus. And I've got p equals plus or minus square root of 7. And this is number 5. P equals plus or minus square root of 7. P equals plus or minus square root of 11. Once again, the way that MyLab works is instead of saying p equals, you have to just put the answers down in braces. I think the easiest way is to use the plus or minus button, square root of 11, comma, plus or minus button, square root of 7, and close the brace, which is already actually written for you. Ah, geez. Okay, let me try that again. Close the brace. Okay, and there's the answer. All right. Number 6. Well, this thing already looks like quadratic in form. Actually, this is a quadratic. This is one of those moments where, I mean, if you multiplied everything out and then solved it as a quadratic, it would still work. But we got this new, technique. Let u equal, this nasty stuff inside. And then we have an easier quadratic, let's say. This is already a quadratic. But we'll have an easier quadratic if we sub u in for x minus 9. And once again, my little trick still worked, right? Here's that linear term right here. And what did I say? Take a look at that guy and use that for your sub. And we did. And it does work. Okay. Anyhow, we're going to do our u sub. Replace this first piece with u and replace the second binomial of x minus 9 with u. And we've got a nicer u squared minus 6u minus 7, a nicer quadratic. We're asking for what numbers will multiply to negative 7 and add to negative 6, and that's just going to be negative 7 times 1. Because of that 1 in front, this is an easy problem, right? U minus 7 times the quantity u plus 1 equals 0. Set each factor equal to 0, so u equals 7. Set the second factor equal to 0, u equals negative 1. Our let statement said, now we want to solve for x. Look at that original problem. There was an x in that original problem, right? And we got u's. So we need to replace every u with x minus 9. And then just replace, copy down the rest of the equation and solve it. Well, add 9 to both sides. X equals 16. Add 9 to both sides. X equals 8. And we only get two answers, x equals 16 or x equals 8. By the way, there is a formula that we look at, or a theorem that we look at in pre-calculus much closer. Basically, is showing that, if your equation is second degree, you could have at most two answers. If your equation is fourth degree, you could have at most, well, it says you're going to have 4 solutions, but you also could get repeating solutions, okay? So if you count repeating solutions as an equation, then you're going to have exactly 4. And once again, 4 power, you're going to get 4 answers. Okay. All right, where are we at now? Let's look at number 7. And, what's my little trick? Well, I take a look at that. Right, this is second power, that's first power. So why don't we take a look at the base of that first power, and that helps me to realize, there's my sub. Let u equal y squared plus 4. Now, is this a second degree or fourth degree equation? Well, when you multiply all of that out and then square, if you square this binomial, you're going to have y squared times y squared, which is y to the 4th. So there's going to be 4 solutions. All right, now let's go ahead and do our u sub. Our u sub, which says that we are going to replace this binomial with u, and this identical binomial with u. And now I've got u squared plus 19u plus 84 equals 0. I definitely have a quadratic. That's because this original problem was quadratic in form. Now just temporarily turn it into a quadratic. What two numbers multiply to 84 and we'll add to 19? And as we think about this, you can see if you can hone in right to the answer, or you could just systematically go through 1 times 84 and write down the list. That probably is a little bit longer than you need to. You start to get the sense, that I'm going to multiply to 2 numbers to get 84, and I've got to add to 19. Well, these 2 numbers need to add to 19, and 1 and 84, 2 and 42, that's not going to happen. So you probably don't even have to start with such small factors of 3 times 28. That's not going to add to 19. 4 times 24, that's not going to, so I didn't have to start there. How about 6 times 14? Well, that's getting closer. That adds to 20. And then how about 7 times 12? That's looking really good. That adds to 19. So I probably could have just gone down. At least maybe I would have started here. Anyhow, that's just optional stuff. 7 times 12 is 84, and 7 plus 12 is 19. Because there's a leading coefficient right there of 1, this is going to be simple. U plus 7 times u plus 12 equals 0. Set each factor equal to 0, so u equals negative 7. Set the second factor equal to 0, so u equals negative 12. Now we wanted to solve for what? Y. We need to sub back in y squared plus 4 wherever we see a u. So y squared plus 4 goes there, and y squared plus 4 goes there, and that equals a negative 7, and that equals negative 12, copying down the rest of the equation. We're going to subtract 4 off both sides, which just gives us y squared equals negative 11. And how do we solve that? We square root both sides, and we don't forget plus or minus. So we now get y equals plus or minus. The square root of 11 is not going to simplify. However, a negative under the radical could be written as a imaginary number. So there's my first two answers. This is going to be subtract 4 off both sides, so y squared equals negative 16. Of course, we square root both sides, and we never forget our plus or minus. And we get y equals plus or minus. The square root of 16 is 4, and don't forget your I under the square root, negative under the square root, which gives us an I. So we get 4 answers, and those 4 answers are y equals plus or minus the square root of 11i, or y equals plus or minus the square root of 4. All right, number 8. Number 8, okay, that definitely is not a quadratic, but can we write this as a square minus 10, that's to the first, minus 24 equals 0. And what's my trick that I keep on talking about? How about if we take a look at that second term there and see if that in fact is my sub. Let u equals the square root of x. Let's write in the square root of x and see if that in fact does work. Well, the square root of x squared, the square root of, my dog, the UPS guy just showed up and the dog goes crazy. I don't know if you could hear that. Anyways, the square root of x squared is in fact just x. And the square root of x raised to the first power is just the square root of x. So the two equations are definitely equal to each other, and the only reason why we did this is to show that the square root of the square root of x can be replaced with a u. We're doing a u sub. Now we just turned this non-quadratic equation into a quadratic equation, which just allows us to use all these awesome tools to solve a quadratic equation. What two numbers multiply to negative 24 and add to negative 10? Well, I think that's going to be what? Negative 6 times, no, that's not it. Got all excited there. What number is this? Number 8. That's going to be, wait, what did I do something? Okay, anyhow, I'm getting a little distracted here. But anyways, what two numbers multiply to negative 24 and add to 10? How about negative 12 times 2? Yeah, multiplies to negative 24 and adds to negative 10. Because of the leading coefficient right here, we know that this is easily done without any grouping or difficulties. U minus 12 times the quantity u plus 2 equals 0. Set the first factor equal to 0 and u equals 12. Set the second factor equals 0 and u equals negative 2. We go ahead and square, no. Wait, did I put everything in? Oh, what am I doing? I'm definitely distracted by the UPS and doggy outside. Okay, anyhow. So now what we want to do is wherever we see a u, we're going to replace it with the square root of x. There's my u, replace with the square root of x. There's my u, replace with the square root of x. Write the rest of the equation. Square root of x equals 12. Square root of x equals negative 2. Now what do? How do we solve square roots? Well, we can undo a square root by squaring. And I want to put a big star right here. Because remember, whenever you square both sides of an equation, you must what? You must check for extraneous solutions. So that is a must. So now we end up getting square root of x squared. So the power of 2 and the index of 2 are inverses. So we just get x, and 12 squared is 144. I got to check that. So don't call that an answer yet. We must check it. Square both sides. That's a square. Square both sides, and we get x equals negative 2 squared, which is 4. We must check it. So let's go ahead and do these checks. In fact, I'm going to, let me move this over just a hair, just so I have more space to check. So I need to run a check on this. I'm going to say check. Oops, that's the wrong thing, the wrong tool. I need to say check. And so what is the check? You got to go back to the original problem. The original problem said x minus 10 times the square root of x minus 24 better equal 0. So what did I get on this particular one? Well, I got a 144. So I want to see if this in fact equals 0. 144 minus, this is 10, and the square root of 144 is just going to be 12. Right, square root of 144 is just going to be 12. And now I've got 10 times 12 is negative 120 minus 24. And 144 minus 120 minus 24 is 0, which checks out. That means that this is in fact a good answer, and it's checked. We had to check it because what did we do? Because we squared both sides of the equation. So we had to check our solutions. There's the first one. We must also check our second solution here. I'm going to write check. We must check this also. And it was going to be my answer minus 10 times the square root of my answer minus 24 equals 0. And we run a check. We're going to try 4 this time and see what happens. So we got 4 minus 10. Now the square root of 4 is 2 minus 24. We got 4 minus, so 10 times 2 is 20 minus 24. And this is going to equal 0. I don't think so because when I run through this, I get what 4 minus 20 is negative 16 minus 24 is what negative 40, which definitely does not equal 0. This is an extraneous. That's an extraneous solution, which means we cross out that answer. It did not work. We only have one solution, and that one solution is x equals 144. All right, next problem, and this looks very similar because of the setup, right? Once again, the philosophy is, can I rewrite this as a quadratic? Something, or 6 variable to the second power plus 29 variable to the first power. I'm going to subtract 5 just to put it in standard form. So as I said before, the key here is to take a look at this term, and that pretty much tells you your u sub. Let u equal the square root of x. So I'm just going to take that extra step to verify it with ourselves that that does work, and I feel pretty comfortable saying that when I square when I take the square root of x squared, I just get x. And then the square root of x to the first power is the square root of x. And the rest of it's the same. So I've got equality there. I'm going to do my u sub. Every time I see a square root of x, I'm going to replace it with a u. And this turns this nasty-ish kind of problem into something easier, because it's a quadratic, and we've used quadratics, so we've done a lot of work with quadratics. We want to see what, now I've got that leading coefficient, so it gets a little more complicated. 6 times negative 5 is negative 30. Right? 6 times negative 5 is negative 30, and adds to 29. Now, if we're going to multiply to get a negative, one must be negative, one must be positive in terms of the factors. And I'm saying a positive 30 times a negative 1 is negative 30, and a positive 30 plus a negative 1 is positive 29. So I can see the two numbers. Now, how do we do this? We've got many different ways to do this problem. We've done it with grouping before. You could do it by grouping. By the way, you could also do this by completing the square or by using the quadratic formula. But it is factorable, and it just factors down to 6u minus 1 times u plus 5. And you can do that by trial and error, guess and check, grouping, or complete the square or quadratic formula. So there's different ways to do that. You could always double check yourself too. 6u times u is 6u squared. The middle term just comes from 6u times 5 is 30u times minus 1u, which is 29u, and negative 1 times 5 is negative 5. So if you multiplied it out, you would get that. So we did do it correctly. So we go ahead and solve. set each factor equal to 0. We got 6u equals 1. We divide by 6, and we get u equals 1/6. Set this factor equal to 0, and we get u equals -5. Now, I don't want to know what u is. I want to know what x is, and I can see when I see a u, replace it with the square root of x. When I see a u, replace it with the square root of x. When I see a u, replace it with the square root of x. Okay, how do we solve this? Well, we have to square both sides. And once again, ring the bell, do whatever you do. Sound the alarm. That was kind of dumb. Anyways, must check. You must check your answers for extraneous solutions when you do this. So we're squaring both sides, and you must check your solutions. So we end up getting x equals 1/6 times 1/6, which is 1/36, and x equals -5 times -5 is +25. And you might remember from the past, negative like that, that's going to make it extraneous. Yeah, a simple problem like that, you kind of see it coming. Some problems you don't, you can't see it. But anyways, we'll go ahead and just do our checks here. And once again, I'm going to do this to gain some space, move that over a little bit. And let's do our check. Check. Well, the original problem was 6x plus 29, so 6x plus 29 times the square root of x, I believe, equals 5. Okay, so what's our value we must check? Well, we must check a 1/36. So 6 times 1/36, right? That 6 is up top, so it's just 6/36, which is just 1/6. And this is going to be plus, so plus 29. The square root of 1/36 is just going to be times 1/6. So this is now plus 29/6. And common denominator, we just add them up. This gives us 30/6, which equals 5. Hey, how awesome is that? The left equals the right, so therefore this answer of 1/6 is checked and is good. We need to do the same for the next one, the next problem, and we'll go ahead and use green to check. What was the original problem? It said 6 times my answer plus 29 times the square root of my answer is supposed to equal 5. So in this case, I'm putting in my answer of 25. And on this one, what number is this again? This is number 9. Number 9, we've got 6 times 25, which is 150, plus 29, and this square root of 25 is 5, so we must multiply that. So we got 150 plus 29 times 5 is 145. This is getting way too large. When I add those two up, I get 295, which definitely does not equal 5. This is for sure going to be extraneous. So we cross that answer out and do not use it. I just get one answer, x equals 1/36. Number 10. How many more do we have here? 10, 11, 12, 13. Okay, number 10. Ooh, something different. Well, couple different ways to do that, but I think let's just stick with the plan here. X to the -2nd plus 2x to the -1st. I'm going to subtract 63 just to set it equal to 0. Okay, well, what was the plan that's been working really well? That second term tells us a good u sub to use. Let's let u equal x to the -1st. And let's see if that in fact works. Remember, we are trying to see if this nasty thing can be written as a quadratic, and that would be something squared then plus 2 times something to the first power minus 63 equals 0. And I want to see, in fact, does this work if I put a negative 1, x to the negative first. And yes, x to the negative first squared is x to the because, right, when you have a power to a power, you multiply, so negative 1 times 2 is negative 2. And so those are all equal, so that allows us to really see that I can do a u sub here. And so that's u squared plus 2u minus 63 equals 0. What multiplies to negative 63 and adds to 2? Well, how about positive 9 and a negative 7? Because that leading coefficient is 1, we don't have to worry about grouping or anything more complicated. We just say u plus 9 times the quantity u minus 7 equals 0. Zero factor property, set the factor equal to 0, so u equals negative 9. Set the second factor equal to 0, u equals positive 7. We don't want to solve for u, we want to solve for x, so we replace x to the negative first with u. Replace u with x to the negative first. So x to the negative first equals negative 9, x to the negative first equals 7. I've got two ways to solve this. This first way, I'm going to do it this way, which is realizing that x to the negative first equals 1 over x, right? So that's a fact. So we can replace x to the negative first as 1 over x. And then we can solve this. I don't know. Isn't it a proportion? Couldn't you cross multiply? So you get negative 9x, cross the other way, which gives you 1, divide by negative 9, and x equals negative 1/9, right? That's a possible way to do it. Let's do it the same way both ways here. We know that x to the negative first is just 1 over x. I know 7 is 7 over 1, so I could just cross multiply, giving me 7x equals 1, divide by 7, and x equals 1/7. I didn't square both sides, so I don't really have to check, but checking if you have time is always a good idea. So I get two answers, x equals negative 1/9, x equals positive 1/7. Let's take a look at the next one. Is this the same? Yeah, this is the same kind of problem. So we're going to do it again. This one has a leading 30, which makes a little more challenging. But I'm going to show you another option for just this last piece right here. There's a second way to tackle it if you want. Well, once again, I want to subtract 6 on both sides just to kind of get this in a better form. It's not quadratic form yet, but it is equal to, set it equal to 0. And once again, the question is, can I write this as a quadratic? That term right there helps us to realize that most likely let u equal a to the negative first, and we can achieve our goal of rewriting it as a quadratic. Okay, so that's good. Go ahead and replace with u, and we get 30 u squared plus 31 minus 6 equals 0. All right, well, this one is a bigger number to deal with. The leading coefficient is 30. And by the way, if you saw something that looks just too, you say, I'm not going to factor, that's too hard. You could do what? You could complete the square, and that's pretty hard. But you could also, I don't think I'd complete the square with this one, but you could also use a quadratic formula. As long as you have it memorized and know how to use it, that can be pretty quick as well. Let's go ahead and factor this one since it is factorable. 30 times negative 6 is negative 180. What multiplies to negative 180 and adds to 31? And you can look, get your list going. 2 times 90, 3 times 60, 4 times 45. Let's see, if it's going to multiply to a negative, I've got to multiply a negative times a positive. So I've got to subtract these two numbers. 5 times 36. Ah, there it is. So it's going to be 36 is the positive and 5 is the negative. So that multiplies. Let me try that again. That multiplies to negative 180 and adds to positive 31. All right. So then let's go ahead and do this by grouping just to review that again, I guess. These are our two numbers that are going to replace the middle term, negative 5 and 36. So we got 30u squared. We're going to replace this with, we'll replace with positive 36, positive 36u minus 5u, and of course that's the same as 31u. Copy down minus 6 equals 0. Okay, now we group it. What can we factor out of those two terms? Well, it looks like I could factor out, what can I factor out? What do I have? 30u squared. Looks like I could factor out a, let's see, somehow I think I, 30u squared, 5u. Oh, okay. So I did it a little differently when I did it on my paper. In fact, I put the negative 5u first. I put a negative 5u here and a 36u there. But I'm just going to go ahead and do it this way because both ways should work. I mean, they don't always work, but sometimes you have to switch these two middle terms if your grouping doesn't work. But I'm pretty sure this is going to work either way. So let's go ahead and just give it a shot. So I can factor out what's common. What is it, a 2? Yeah, so I'm going to factor out a 2. Or is it more than that? I'm trying to think here. Let's see, 2. So we factor out a 2, u, and this gives us 15 u plus, shoot. What am I doing? I am not thinking much here. So I'm going to factor out a common 6, right? 6u, that looks better. So if I factor out a 6u, that leaves me with 5u plus 6. Okay, so let's just double check that since I was a little weak there. 6u times 5u is 30u squared, and 6u times 6 is 36u. That looks good. All right, now let's see. Now I'm going to have to get a matching binomial here. So I'm going to write it down. What can I factor out of this to get 5u plus 6? And that's a negative 1. So negative 1 times 5u is negative 5u, and negative 1 times 6 is negative 6. Okay, so we did it. That was a little rough, but we did it. So it's 5u plus 6, and we factor by grouping, and we get 6u minus 1. All right. Now what do we want to do? Set each factor equal to 0. So we've got 5u equals a negative 6. Divide by 5, and we get u equals negative 6/5. Set the next factor, 6u equal to 0, so 6u equals 1. Divide by 6, and u equals 1/6. Now what was our u sub though? U sub, it said to replace u with a to the negative first, so we got to sub that back in. A to the negative first, a to the negative first. So this is where I want to tell you that you have an option. You have an option here. Remember last time I said, okay, you can write this as a to the negative first is 1 over a, and then just cross multiply, right? A lot of people like that because you've been cross multiplying forever since you're much younger. So people are really familiar with that, and that's fine. But another way to do that is I know I need to solve for a, and how can I make a to the negative first just a? Well, if I raise it to the negative first power, right? Wouldn't that do something for me? Let's think about that. If I raise it to, okay, actually there's a couple, no, let's just do it that way. Okay, so we raise it to the negative first power. If I raise the left to the negative first and the right to the negative first, what happens when you raise something to the negative first? It actually takes the reciprocal. So So this -1 times -1 gives us a, and this is just its reciprocal. So that is probably the fastest way to do it. So I get a equals -5, 6. If you didn't like that, if you did not like that at all, you can just go ahead and remember the rule x to the -1st equals 1 over x. So a to the -1st is just 1 over a, right? And so then at that point, you can cross multiply, or even really even quicker, what you can do is you can realize that if you took the reciprocal of 1 over a, you get a, and if you took the reciprocal of 1 over 6, you get 6, okay? But sometimes those little tricks or whatever can really frustrate students. So I'm just showing you some shortcuts that do work. You could go ahead and go back to a times 1 is a, and 6 times 1 is 6. And there you go. We've got the same thing that we got before. So I was just trying to show you there's multiple ways of finishing out that problem. So we get -5, 6, and a equals 6. Okay, we're almost done. Number 12. And once again, can we rewrite this as a quadratic? And so once again, my recommendation is always to take a look at that second term and see if that actually does work. Let u equal x to the 1/3. And so we go ahead and take that as a recommendation and see if this is in fact equal. And when I multiply 1/3 times 2, I get 2/3. And when I multiply 1/3 times 1, I get 1/3. So those two equations are equal, and it helps me to see that I can substitute with u. And so I get u squared minus 2u minus 8 equals 0. And hey, this is actually looking really good. What multiplies to -8 and will add to -2? And I'm thinking, how about -4 times 2? So this factors down nice and a nice easy way. U minus 4 times the quantity u plus 2. Set each factor to 0 and you get u equals 4, or u equals -2. Now what was our u sub? Replace u with x to the 1/3. And copy down the rest of the equation. Now, using the idea back here, that basically said I had a to the -1st, and how can I turn a -1st into a 1, first power? I multiply it, raise it to the -1st. -1 times -1 is 1. So that same sort of similar logic, because ultimately I want x to the first power. So if I take this and raise it to the third, right? 1/3 of 3, or 3 over 1 times 1/3 gives us that x to the first. So there's my logic. I'm raising both sides to the third power. And so I get x equals 4 cubed, which is 64. Same logic on this guy over here. If my goal is to get x to the first power, why don't I raise it to the 3, or to the third, which is going to give me x to the first power. And then of course I've got to do, I've got to do both sides. And this gives me x to the -8. Okay, I raised it to an odd power, so I'm really not super concerned about extraneous solutions. You could always check your work is never a bad thing. Okay, and so we've got, but I didn't raise it to an even power. Even powers turn negatives into positives and really cause problems. But as you can see, -2 to the third power didn't change its sign at all. Okay, let's go on to our final problem. And we've got, once again, can we write this as a quadratic? I'm going to subtract 2 from both sides, so I got -2 equals 0. What's my recommendation? Recommendations, take a look at that guy right there. And let's let u equal x to the 1/3. Now if I write this as 1/3, x to the 1/3, does that in fact work? Let's see, 1/3 times 2 is 2/3. That worked. 1/3 raised to the first power is 1/3. So yes, these two equations are totally equal to each other, and I'm going to replace x to the 1/3 with a u. So now I got u squared minus u minus 2 equals 0. There's a leading coefficient of 1, so this is going to be pretty easy to factor, I believe. What multiplies to -2 and adds to -1? And that's going to be a -2 times 1 is -2, and -2 plus 1 is -2. So this factors down to u minus 2 times the quantity u plus 1 equals 0. Set each factor equal to 0, so u equals 2. Set the second factor equal to 0, so u equals -1. I didn't want to know what u is, I wanted to know what x is. So I sub back in x to the 1/3 for u. X to the 1/3, x to the 1/3. I get x to the 1/3 equals 2, x to the 1/3 equals -1. How do I undo a 1/3 power? Well, I raise it to the third power. And undo, what I mean by undo, it makes x to the first, which I'm always solving for x to the first. 2 cubed is 8. Raise both sides to the third power. This gives me x equals -1 cubed is -1. Got my final answer, x equals 8 or x equals -1, and that is it. And I hope that helped out. And let me zoom out. Okay, and I hope everybody has a great day. Take care and talk to you soon. Bye.